Hey guys, we're going to be jumping in here with Chapter 6, where we're going to be looking at something called scientific notation. So what you're going to learn today is to write numbers in both standard form and in scientific notation. So here's an example for you to copy out into your notes. This is the number in scientific notation. This would be in standard form. The key thing I want you to pay attention to is that these are equal, meaning this is the same number as this. These are just different ways of representing those two different values. So here it says a number is in scientific notation if the first factor is greater than or equal to 1 and less than 10, and the second factor is a power of 10. So make sure you copy this definition. This is very, very important. This first number is greater than or equal to 1 but less than 10. In other words, there is just a digit in the ones place. It must be that way. So here's an example of 1. This is 1.54. That must be that way. This is 7.45. That's fine. If you had something like this, 12.3 times, I don't know, 10 to the 4th, that is not in scientific notation because that's 12.3. It'd have to be 1.23 times 10 to the 5th. And we'll look at moving those things around a little bit later. But first, here's our daily funny. How does NASA organize a party? They plan it. Boom, boom, boom. I like this kid's belly hanging out. Why is it that babies always have their bellies hanging out? Mine always do. All right. Writing in standard form, it says the temperature at the sun's core is about 1.55 times 10 to the 7th degrees Celsius. Write the temperature in standard form. The way you do this is you rewrite this first number. So I have 1 and 55 hundredths. And when it is a positive exponent, I'm going to move it the number of times of this. And here's why. What this says is 1.5 times this number. I'm multiplying these. So if I put these in a calculator, what I end up getting is the correct answer. But that's not what I'm looking for here. I just want the quick way of doing it, but the quick way is because of this. So let's see. I want to erase some stuff. Let's get that. The exponent tells you the number of times that you're going to move the decimal. All right, so this is 7. So I make little like ocean waves here. So I have 1, 2, 3, 4, 5, 6, 7. And that's where the new decimal is going to be. Now the problem you may be thinking to yourself is, well, what goes in here? There's all these gaps. You fill that in with zeros. So I have 0 here, a 0 here, a 0 here, a 0 here, and a 0 here. I'm going to rewrite the entire number without two decimals, because I can't have two decimals, so that doesn't make sense. So I have 155, and then it looks like I have 5 zeros. Go back and put in my commas. So this right here is my answer. Do not leave it like this. I will count this incorrect because I don't know what decimal you're looking at. I need it rewritten all the way through. Okay, so there's that. Hopefully you have that copied down. Here's one for you to try. The answer will be up in 3, 2, 1. All right, that's what I got. Hopefully you got the same thing, and we're moving on. Okay, so writing in scientific notation. We're going the other way here. It says a supercomputer can perform whatever that number is. Let's say it's millions, billions, trillions. 135 trillion, 300 billion operations per second. Write this quantity in scientific notation. In order to do this, we're going to go the opposite way of counting our decimal. So our decimal was here. I want it to go all the way to here. So how many places does that go? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 spots to get my decimal there. So how many ever number of spots that is? I rewrite my number with a decimal like this. Remember, it has to be between 1 and 10. And then I multiply it by 10 to the power of whatever number that had to move, which in this case we just said it was 14. So the decimal here, notice it's between 1 and 10, or 1 or greater than or equal to 1 and less than 10. That's what this is. Times 10 to the power of number of times the decimal has to move. So here's one for you to try. The answer will be up in 3, 2, 1. There you go. Hopefully you got the same thing. If not, go back and check your work. All right, so here, numbers less than 1, it says write the quantity in scientific notation. This is a little bit different. I'm still counting decimals. Now remember, this first number has to be between 1 and 10. So I have a 7 and a 6, which means that first number is going to be 7.6. And I'm multiplying it by 10 to a certain power. If it is a decimal, a really tiny number, then that means I'm going to have a negative exponent. And the negative exponent is going to be the number of times that the decimal has to move again. So I have 1, 2, 3, 4, 5, 6 times. So it's going to be 10 to the negative 6. So 1, 2, 3, 4, 5, 6. So again, you're just counting. The only difference here is that I'm writing it out as a negative. Okay, so make sure that you're doing that. So again, this is very similar to what we were just looking at. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. And there it is, your answer. So if you did not get that, go back and check your work, see what you did wrong, try to correct it. I believe that's it for today. Yep, short video, so I'll see you in class.